Okay, so in this problem, we have a ladder that's 10 feet long that rests against a vertical wall. And it says if the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, so again, with related rates problems, start off by drawing a diagram and label it mathematically, and then define what you want to find, using derivatives and equations. So a wall here. The ladder, let's have this will be our ladder. So from here to here, that's 10 feet. We'll treat this as the y-axis. This will be the x-axis. And saying if the bottom of the ladder slides away from the wall at a rate of 1 foot per second, so then this is the bottom, this part is sliding away at a rate of 1 foot per second. So it's going in to the right. And so we can say basically dx dt is 1 foot per second. And we're trying to find how fast the top of the ladder is sliding down the wall when the bottom of the ladder is 6 feet from the wall. So this is the top. So we're looking at dy dt. We want to basically figure out how fast this point is moving down as this point is moving to the right at a rate of 1 foot per second, and at the moment when the ladder is 6 feet from the wall. So when the distance from here to here is six, per se. So we got a relationship here with a right triangle. So this is, remember, this is we'll call this our y. We'll have this, our base be our x. And the hypotenuse is 10. So we got is x squared plus y squared equals 10 squared. And we're trying to find dy dt when x is 1, or sorry, when x is 6 and when dx dt is 1. So let's figure out how we can relate these three variables to the differential equation. And all we simply have to do is differentiate this with respect to t. So essentially treat it like an implicit differentiation problem. So what we got going on here is that if we differentiate each of these with respect to t, we got, oops, 2x times dx dt plus 2y times dy dt is equal to 0, since 100 is just a constant, so it's equal to 0. Now, we have an x value, we have a dx dt value, we're trying to find dy dt, so we need to now figure out what the y value would be. So the y value, let's put it over here, because that's what we're gonna fill in our value for y. Remember, we have this as our equation that relates x and y, and we're trying to figure out y when x is 6. So let's just go 6 squared plus y squared equals 10 squared. And then so you got 36 plus y squared equals 100. So essentially you got y squared equals 64, and y is 8. So y is 8, x is 6, dx dt is 1. And now we can simply just solve this for dy dt by plugging these values in. Let's go ahead, let's do that. So we got 2 times 1. Sorry, no, 2 times 6, x is 6. 2 times 6 times 1, because dx dt is 1, plus 2 times y is 8, times dy dt equals 0. treat dy dt like it's a variable term. It's not technically really like that, but it works in this case for that. So let's subtract this and divide by 16, and we'll get dy dt. So working this out, we'll have 16 dy dt is equal to negative 12. And we just divide both sides by 16. And then we get dy dt is negative 12 over 16, or negative 3/4. And using the proper units, we're going to say that it's negative 3/4 feet per second. Well, so that negative, remember, that negative talks about the direction that the ladder is moving. So then this would make sense because it's saying the ladder is moving in a negative direction at a rate of 3/4 feet per second. And there you go. That's all there is to it.